In this video, I will be discussing recursive models. And in this case, in this video, we're talking about linear models. So I want to take you back to the olden days. Back before we had computers, back before we had, um, the fancy kind of, I think a lot of employers now use like a card, like a credit card kind of thing, and you would scan it or something, and that would tell the computer when you actually arrive at work. But there was a time when those things didn't exist, and what we would do, hourly employees, we would punch a clock. This is a punch clock, and that card the man is holding there looks like a man. I don't know. The hand is holding is would be called a punch card. And the way it would work is you put that card in the clock, and then the clock would go like chunk, and it would leave a little uh, ink imprinted timestamp on there with the date and the time to the nearest minute. And that's how we would clock in back in the olden days. Well, when I was in college back in 1986, I worked for Pay and Pack. Some of you might remember Pay and Pack. It was a home improvement store, and it was located where Broadway Cinema 8 is now located in Eureka on Broadway. In any case, back in those days, we got paid $6.48 an hour, and I was a salesperson. Now, the thing about it is, a lot of employers back then, and I honestly don't know exactly how the employers do it these days. I suspect that you can get paid for every minute you work these days because everything is computerized. But back in these days, it was not uncommon to get paid by the quarter hour. So in every quarter hour you would work, you would get paid for that increment of time. And of course, depending on the employer, the rules were probably different. And a lot of times if you were late, it was a really big deal because as soon as on the hour, most employers would start paying you. So every minute you're late, you're costing them money. You're not on the job. So I think there were some employers that if you were too late, you would lose that first quarter hour of pay. But in any case, the idea here and what we want to focus on is that you can think of this as getting paid $1.62 for every 15 minutes you're at work. Now, the way we're going to think about it is in terms of a recursive process then. In this case, I'm not thinking about time as being continuous. I'm thinking about time being in like 15-minute packets. So recursive means characterized by recurrence or repetition. And what we're going to be talking about are called recursive processes. In this example, we're talking about Pay and Pack, paying $1.62 for every 15 minutes. And as I go through this example, I'm going to also demonstrate the notation we usually use for when we're talking about recursive type processes. So the first thing I'm going to put down here is P sub 0, and this is going to be pay for working zero hours. Now at Pay and Pack that would be 0, but it doesn't have to be that. It could be, I can imagine a situation where when we get paid for showing up, say, I don't know, a certain amount. It's possible. So P for the first quarter hour would equal P naught, or P sub 0, plus $1.62. P2 would then be P1 plus $1.62. So the idea here is I take the previous pay amount and I add another $1.62 for it for the second quarter hour. Now another way to think about this is we realize that P1 is equal to this quantity, so we could just substitute that in for P1. So I'm going to put parentheses in. I don't really need them, but I just want to emphasize that I'm taking P1 and replacing it with P0 plus 1.62. And the second 1.62 is coming from right here. Now, if we do some basic simplification here, normally I'm not going to write the parentheses because now I'm just going to take them right back off. And also, I'm not going to actually add 1.62 to 1.62 here, which I could do, because the way I want to think about it is as 1.62 times 2. So there are two of those terms. And this is going to be a simple, we'll see in a couple of steps, this will be a simplification. So P3 is going to be P2, this one. So notice the idea of recursion is the previous amount goes into the next recursive equation. And we're going to add another $1.62 to P2. And of course, P2 is P1 plus 0.62, which is also P sub 0 plus 1.62 times 2. Should be a 1 there. So can you already begin to see a pattern here? For the third quarter hour, we're adding 3 quarter hour pay amounts to the initial amount of pay. These 3 dots are indicating that we could continue this process as long as we want, really. We could continue it to, well, let's see, how many quarter hours would be 18 or 8 hours? 8 quarter hours, that would be 32 quarter hours. So P32 for an 8-hour day would equal P sub 0 plus 162 for every, that would be times 32 because there were 32 quarter hours. Now we could also generalize this even further. By thinking about what would P sub n be. So for any number of quarter hours, we could write this formula as the initial pay amount plus $1.62 times n. Now, one of the things you might be asking yourself, why would we go through all of this or what have you? And one reason is because it's an example of a linear recursive process. But again, back in the days I'm talking about, before this idea of punching a clock existed before handheld calculators were even around, and way back, even before there were handheld calculators, of course, people were pretty good at arithmetic, I guess, so they could calculate this by hand. But often employers would have charts like this on the wall or something. So you could look at the chart and see that, oh, I worked 3 hours, I worked 3 hours and 3 3/4 hours. That would mean I should get paid $24.30 or something like that. So they also had tables like this to calculate sales tax and things like that back before digital calculators and electronic calculators were available widely. Today, you can get a very basic solar calculator that does basic arithmetic for a few dollars. But those didn't exist, back in the 1970s or something, say. Now the other thing we can look at a graph of this recursive process. And when you see the graph, I hope you see straight away why we call this a linear recursive process. It's because the pattern that we're seeing in each, these are ordered pairs, each point represents the amount of time in a quarter hours, 1 1/4 hours say, we can project across. So this graph's a little bit hard to read because the increments, but we could estimate, we're going by $10 increments on the axis, so it's hard to, maybe a little bit hard to see, but we could estimate that. But the pattern is apparent, and this is why we call it a linear process, or a linear recursive process, or even, I guess we could, call it linear recursion. In any case, that's it for this video, so I'll see you next time.